Welcome everyone. In this video we will start talking about testing in Rust. We know that testing is very important, especially for production-ready applications. We will start with some simple examples and then we'll see the anatomy of tests in Rust. Something that is really great is that in Rust you don't need an external package to install like Jest or other JavaScript packages, for example, but it's embedded in the language. So you can start creating tests right now when you start a new project, and this is a great plus. We'll make some examples and there is also a tricky question in the video. See you, bye. So let's see how tests are written and done in Rust. Tests in Rust are written in the same file. We'll also talk about best practices and how this is done. And the bodies of tests are marked with this hashtag and in square brackets test attribute. Sometimes I call them annotations because they're very similar to annotations in other languages. To be precise, those are called attributes in Rust. You know, it's something on top of a function. So usually the test functions, because tests are functions in the end, they have three main tasks. The first one is that they set up any needed data or state to actually test the function or whatever. Then they run the code that you want to test. It's a test function. It's not just another random function. And then basically it will return the results, if the results are expected or not. To make it simple, a test might succeed or fail. And I think that the most important part, like many things in programming, is to understand the anatomy of a test function. How do we write a test function? And this is exactly the code that you get if you type cargo new, a name of a project, in this case is called other, -- lib. In this case, you don't have a main.rs file, but you have a lib.rs. And this is the exact code you should have, the same as me. I left here some comments just to start the presentation. So we have a function here, public function add, and these are the parameters, left and right. Usually this is how they are called in Rust. And then we return unsigned sides, which is the sum, the addition of the two. And then you see we have this attribute CFG test. We import this module test, and then we have this use super. Basically, we are importing everything which is in this module. And then we have a function fn, it works. This is the name of the function. We have a result, and you see here this assert equal. So I want to check if the result of the left plus right is 4 here, in case I have 2 and 2 as inputs. I just want to stress out that the cargo.toml file, that is similar to package.json or requirements.txt, is empty. So we are not importing a specific library or framework for testing. This is embedded in the language, and I really like this. Now, to run this test, what I can do is to type cargo test. So not cargo run, but in this case, cargo test. Let's see. And let's read the output. Compiling, running one test, it works, test result, okay. And this is our first successful test in Rust. So this does mean that if we have as inputs 2 and 2 for this function line 14, the result is 4. Of course, we will do trivial examples today. It will not seem that useful. The goal here is not to make a complicated test, but rather to understand the logic behind the tests in Rust. Okay, so the first thing that I want to try is to change the name of the test. Probably I want to create multiple functions, so I want to understand what exactly happens. For example, if instead of it works, I can call this testing underscore function. I'll just change the name. Testing function, Ctrl L, cargo test. Can you see here? We have now a different name. This was just to understand where we should put the function names and how they are in the output here when we do cargo test. So we just changed the name of this function. And the name for the test is just for us when we are basically reading the logs here. Okay, let's do something a bit more interesting. Let's let's make a test that fails. Now, how can you make a test fail? We can do this in different ways. The easiest possible way to make a test fail is actually to call the panic function. The panic function is a special function, wrong test case. We will also do that. Let's do this. Fn it will fail like this. We could do something like this, but I want to do something even more like this. So we call the panic function in the test. Okay, this is actually allowed. Okay, let's try cargo test. Now it failed. No worries. We did this intentionally. You can see here at the top the names of the different tests. The testing function here was successful, and the test it will fail. It failed because it called the panic function. If you want to know more about panic in Rust, I made a specific video on the panic function. It's basically just to close the program as soon as possible in the quickest and also safest way, instead of just letting the randomness to decide what is closed. So the panic is actually a very good thing. Okay, so this was our first test. Now I want to delete this. And let's do a slightly more complicated example. And I want to check in results with the assert macro. And to do this, I want to, as I said, do something a bit more complicated. So we will take an example of something that we did some months ago. When we introduced structs in Rust, we used a rectangle. And this is exactly what we will do here. So we'll have here this struct rectangle. A struct is a compound type that can have multiple types inside this. It's basically for logic. They're very similar to classes. We have derived the bug here because we want to test this. Maybe we want to print something about this struct, otherwise this will not be allowed. I don't want warnings here. I will not actually use the rectangle, but I will just do a test. So I can use this attribute allow dead code. So the compiler will not stress me out that I'm not using the with and hate. And now here I can have a method for this rectangle like this. I think this is exactly what I need. So this is an implementation for the rectangle of this function. If you want to know about methods, I made a lesson about methods in structs. We have the rectangle here as a reference. And then this is basically to check if a rectangle can go inside another one, like a box can go in another box. Okay, and here we are not switching width and height, so they can't be rotated. So basically the width of the first one, it should be bigger than the second one, and the height should be greater than the second one. I also want to put here this allow dead code attribute, so this warning should go away, and it goes. And now we want to actually make this test. Okay, this will be a bit more complicated. So we have this test, you can see here, or import is similar to what we had before. We have one function. This function, this test function, you see we have the attribute test on line 33. So here we can see this function larger can hold smaller, and in case I have the first rectangle with a width of 8 and a height of 7, and the second is width 5 and height 1, the assert should be larger can hold. So this should return true. Let's see. And indeed, the test passes. Okay, if I try here instead of 8 to put 2, for example, so a smaller one, in this case, you see the test fails. I want to put 8 back here. Okay, so this was the first test. Now let's say that I also want to add another test if the smallest rectangle cannot hold the larger one, and it's this one. So smaller can hold larger using the same values you see here, and let's see, this should pass because you see here we have an exclamation mark on line 58. So we are basically saying that the first should be able to contain the second one. You see here, this is the test on line 24, and the second one should not be able to hold the first one. Let's try to type cargo test here. And indeed, we have, for the first time, two tests that passes. So both the function on line 34 and line 48 testing functions, they are passing. This is very good news. So in this case, everything worked as intended. Okay, now let's start to play around with this stuff. Okay, because usually tests are supposed to be there to tell us that we are doing something stupid. Okay, so for example, let's say that by mistake at some point I invert the check here. I check that the width of the first one should be smaller than the second one for it to be contained. This is of course a mistake. In this case, a rare case of me doing an intentional mistake on line 24. And let's try again to run a cargo test. Let's see. So we have that the smaller cannot hold the larger again, but the first one is basically failing the check. So in this case, probably the test helped us to let us know that there is something wrong in our code. Tests are also used for errors that are not just syntax errors, but also logic mistakes, which are the hardest to spot, because for the compiler, this is absolutely fine. For the human logic, this doesn't make sense, because I'm testing if something can be contained in something else, but the container is smaller than the things that should be contained. Okay, so in this case, test probably helped me to check that I'm doing something wrong with my code. I want to do another example, and I want to check how I can test equality with two macros, assert underscore eq with exclamation mark, and also assert underscore ne, which stands for negation macros. Okay, so in this case, let's start with something very simple here, and let's put this function back here. I want to put this very simple function. We'll do a very trivial example here. We have a function that adds 2 to another number. Okay, so I get this a in input, and then I add literally 2 hard-coded. Okay, the function is called add2. And then I have a test that is actually testing if this is done properly. So we have this test here, and then you see on line 22 we use the attribute test, and then we have this testing function, it adds 2, and then we have this assert equal. So we want to check if this is equal, and if I get 4 in case I call the function add2 with the number 2 as a parameter. So let's try this out. To run our test, I can use cargo test here, and in case it worked, so this test is checking that everything here is working fine. But if I do a mistake in my code, and of course here is trivial, but think about having a bigger code base. This function is called add2, and I end up adding 3 instead of 2, and I try to run here cargo test. The testing here is telling me, hey, there is something wrong here, because if I pass the parameter 2 to have 4 as a return, but then you see, check here, it tells me like, hey, you are getting a 5 here instead of a 4. So it's telling me like the expected output should have been 4, but I get a 5. And of course, dumb examples, but think about doing tests with like hundreds of tests. And I think that the most powerful thing of test is when you start changing your code, because maybe when you write your function for the first time, you know what you're doing. But let's say that you go on this function maybe in 3 weeks, and then maybe this function started to be more complicated. Maybe it's calling an API that returns a number. So things might get more complicated, and maybe I'll change something in the code that might actually become a very annoying bug. We are almost done. I just need a couple more examples. So let's see how we can add a custom failure message. So can we add a custom message in the failure of a test? Let's say that we have a function, a very simple function called greeting, that has a name as a parameter, and it returns hello with the name got in input. Very simple one. As a test, I can do something like this. I can have this CFG test and check line 23. The test is testing this. If I call this function with the parameter as a name Carol, I should have in the result something that contains Carol. And let's try here cargo test. Okay, so this test went successfully. Okay, now let's do a slight change here in the code, and let's say that by mistake, or maybe we are refactoring here, instead of returning the name, we return just hello. So we stop returning, I don't know, the name of our user. And you see, of course, here the compiler is already complaining because we are not using the parameter anymore, but this is a warning anyway. Let's see in this case what will happen. Here I try cargo test. I change the line 16. Before there was the commented one, the line 15. Cargo test. We have a warning because we're not using name, but what is interesting here is this. I get a failed. Okay, assertion failed, result contains Carol. Okay, at least we know that this is failing, but we don't know why. We don't know what exactly went wrong. So when we write a test, we can do something a bit more advanced. Check line 26, and here instead of having just assert result contains Carol, I can have something like this. Check it out. Result dot contains Carol, and then I can make a comma, and then I can return a message that will be sent in case the test will fail. I'm basically customizing the failure messages of the test. In this case, you can see line 28, greeting did not contain name. So here I'm talking to the developer who is running the test. And then of course here I can return the result. And this can be very powerful. This can save a lot of time because here I'm returning this error message. Let's see if this does work. Cargo test. We still have the failed, but check here. This part, greeting did not contain name, value was hello. So it's also returning the value here. It's returning what has been the value returned, which is super useful. Even returning the result. So, and this can make a huge difference if we are doing something complicated that we have no idea why the tests are failing. So we can actually modify the error message of a test. For simple tests, probably this is not needed. For more complicated tests, or maybe for some cases, so if we know that this might change, it might be very worthy. Checking for panics with the should panic attribute. Let's try this out. We have a struct with a guess. This is part of a very basic example in the course that has just a number, okay? Maybe we're just prototyping the code here. Then we can have a method for this struct like this. We have this. Let's say that this is a guessing game and the name should be between 1 and 100. Otherwise, the program will stop working. So if I give as a number, for example, 300, this program will panic, will basically stop executing. Now I will write a test, which is here below. Let's read this test. So this test has the test attribute, the should panic attribute, and then we have a function here, greater than 100, and then guess new 200. So I'm testing this function, I'm testing this testing function with the value 200. Now, the question is, do you think that this test, if I type cargo test, will fail or will be successful? I want to give you some time. Let's try cargo test. Is it a bit crazy? Is it a Rust fault? It's not. What are we doing here? Let's try 50 instead of 200. We are expecting the code to panic. If I put 50 here, it fails. It seems like an inverse logic. If I put 200 back, the test is working. Let's stop for 1 second and let's try to understand. So what are we doing here? We are testing if this is panicking correctly. Remember, I remind you this, there is this attribute should panic, because here we want our code to panic. This is a function that if I pass to this function a value which is greater than 100 or less than 1, it panics, okay? Because I want the guess to be with 1 and 100. But here I'm checking if the function is panicking. It should panic. So this is a check. If it doesn't panic, the test is failing. Do you get it now? I'm not testing the value. This is what the function does. The function is testing this. I'm testing this function on line 19. So I say, okay, this function is panicking correctly. If the user will call this function with 200, this will panic and the test will success. Now the should panic attribute should make sense. Should panic. So it actually panics, so the test is succeeded. Cargo test, not cargo run. cargo test, in this case, is successful. It's successful because it panicked. It panicked with a 200. Our code should panic. You see, checking for panics with the should panic attribute. Do you get it now? It's very tricky because our developer brain is focused here. We are executing this in our brain, line 20. But this is the function. We are testing if it's panicking. It's panicking correctly. Got it? Let's make some changes in the code. So let's say that I remove this check on line 20 and I try to run cargo test again. And in this case, I get an error. This is very tricky. So I removed the value greater than 100 to make the function panic. So now the test is failing because it's not panicking anymore, but it should, because we want the number between 1 and 100. Okay, so by removing the condition on line 20, now the test is failing. So how can you handle this in a more graceful way? We can do something like this. Instead of having a single double condition, here I can remove lines 20 to 22 and I can replace them with two separate panics and two separate messages. You see now from line 20 to 28 we have two different panics. If the value is lesser than 1, we get this message. If the value is greater than 100, then we get this message. And now here in the should panic, I can even type the expected, which is something like this, expected. So I can even say what I expect in this panic here. And if I run now the test, now it works, because now if I get 200, it goes here on line 24, panics, and the panic error, the panic message you see is contained in this one. Or I will say this on line 39 is contained in this line 26. Why am I saying this? Because let's say that at some point I do something like this. I do something wrong here. In this case, I get here a failed test. So if I do some mistake here, I know that this is the message that I should have. Or also, for example, this one. Let's say that I switch the error message by mistake. I put 100 here and I return here 1. You see, I switched 101 in the error message by mistake because I'm just dumb. I inverted this. If I do this cargo test, the test here is saving me, is saying, hey, you are not getting the right error message. So here you can see here that we have an error here. I should get, in case the value is greater than 100, something with 100 here. Instead here I get 1 because I just switched the 101. But in the test, it was expecting a message like this. This is the example, I think the most complicated example of today. One quick more example and then we are done. I can use result in test. I made a lesson specific about result, so I'll go quick here, but I want to show you that in any test like this, I can use the result. You see, the output of this testing function can be a result and not just a normal function. So I can have the usual structure of a result which has an OK or error, something like this. So this is just to let you know that I can have a testing function with a result. Let's try it out. And yes, in this case, the test passes. So we saw many different examples for tests. We have an upcoming lesson on how to organize and running your test properly. See you on the next video.